Hey there, third grade. This is Mr. Campbell. Today we are going to be working on lesson 5.1, which is patterns for multiplication facts. And this is going to be on page 169. Now, at the end of today, we want you to be able to say, I can use structure and properties to explain patterns for multiplication facts. And that's what we're going to be looking at today. We're going to be using, I'm going to go ahead and move this out of the way for us. We're going to be using a multiplication table, all right, to help us out as we look at different facts and say, what are the patterns that we see inside of these facts? So we're going to be looking at these, trying to figure out why these patterns exist and what is going on with them as we're looking. So let's go ahead and turn to page 170 to take a look at what I'm talking about today. So here we are on page 170. If you're not there, pause the video and get there now. It says, Yolanda noticed that 4 times 6 is double 2 times 6. How can you explain this? And then it says you can use a multiplication table to find patterns. And when we use a multiplication table, we have our blue numbers over here, and up here are our factors. So here I've got 4 times 6. So I'm going to go to 4, all right? And so I'm looking at my 4, and I cover it up so that way I go, okay, I know that what I'm looking at is what's going across here. And then up on the top, I come all the way over to my 6, all right? And when I find my 6, then I can go, where do they touch? Well, they touch at 24. So 4 times 6 is 24. It's where they come together. Same with 2 and 6 come together right here at this 12. So the question is that when we see 12, and if we double that, we get to 24. Well, why is that? Well, let's come on down here to box B. And box B says 4 is the double of 2. So 4 times 6 is double 2 times 6. 4 is the double of 2. Double 2 is 4. All right. So you can use the distributive property of multiplication to explain this, right? What that means is we took this 4 and we broke it into 2 and 2 because they're doubles. All right. So then 2 times 6 was 12. And if I have 2 of those, then I have 12 and 12, which when we add those together is 24. Okay. That's the pattern we can see here. So let's take a look at our highlighted rows. The product, which is the answer to a multiplication problem. The product of any number multiplied by 4 will be double the product of that same number multiplied by 2. So when I look down here, these numbers, all right, will always be double the numbers in my 2 row. All right. So if I did 2 times 7 is 14. Then if I did 7 times 4, double that is 28. 14 plus 14 is 28. If I did 2 times 3 is 6. If I did 3 times 4, well, 6 doubled is 12. So in all these different problems, that's what we're looking at. We're saying, oh, I can double it because 2 and 2 is going to be 4. So double this will get me to those 4. That's the pattern that we're looking at. Let's go ahead and go to page 171 and see what this looks like on our practice for today. All right, so let's take a look here on page 171 at number 1. It says, how are 3 times 7 and 6 times 7 related? Well, this is very similar to the last page where we had our other one was 4 times 6. So when we had 4 times 6 and 2 times 6, right? Well, 4 was double 2. Okay. So when we take a look here, what are these related? Well, 3 doubled is 6. Oh, so how are they related? Well, 6 is double 3. All right. And as we're doing this today, I'm going to ask you to make sure you're writing down with me because we're going to be filling in a lot. There's no actual like numbers or equations that we're necessarily solving today. So we're just going to be writing things down, and I need you writing in your book with me. All right. Number 2 says, in the table on the previous page, is the pattern that Yolanda found also true for the factors that are multiplied by 3 and 6? Well, let's go back over there real quick. All right. So what they said earlier was anything that was by 2, we would double it in the 4. So 4 doubled is 8. 8 doubled is 16. 16 doubled is 32. Well, they're asking if we look at our 3's facts and our 6 facts, is the pattern still true? Well, is 3 doubled 6? Yeah, 3 plus 3 is 6. Is 6 doubled 12? Yeah, 6 plus 6 is 12. Is 9 doubled 18? 9 plus 9? 18. So does this pattern work? Yeah, it sure does. So come back with me to page 171, and it says, on the table on the previous page, is the pattern Yolanda found true for the factors 3 and 6? And we're going to say, yes. 6 is double 3. All right. So if I can figure out my 3's facts, I can just double them, and then I would be able to go, oh, well, that's what I'm looking for here. All right. All right, let's go ahead and slide over to number 3. What pattern do you see in the columns and rows that have 0 as a factor? So we're going to actually come down here to our multiplication table. All right, here's my multiplication table. Now, if I have 0 as a factor, or if I have 0 as my other factor, what's the pattern you see in our multiplication? Do you see a pattern here? I do. The pattern is our product is always what? The product is the answer is always going to be 0. So when we come back up here, what pattern do you see in the columns and rows that have 0 as a factor? The product, again, you should be writing this down with me, is always 0. All right. Now it says use a property to explain why this is true. So what's a property that we could use to describe what happens when we multiply something by 0? Well, I remember there was a product of multiplication that had to do with 0, and it was called the zero property of multiplication. There we go. Didn't want to get it wrong. Property of multiplication. And that property told us that anytime we times something by 0, we will always get 0 as our answer, right? So this helps us to understand why this pattern is on our hundreds table, or our multiplication chart. All right. Let's take a look at number 5. It says, look at the shaded products. What pattern do you see? And I want you to go ahead and check it out right now. What pattern do you see along these shaded ones? What do you see? Well, I'm giving you some time because I want you to really look at this and see if you can figure out what pattern do you see. I see one which is 0, 8, 14, 18, 20, 20, 18, 14, 8, 0. If I put a line down the middle, they are like a mirror of each other. I start with 0s, then 8s, then 14s, then 18s, then 20s in the middle. All right. So what's the pattern that we see? I see the numbers, same numbers, going towards the middle. Right? We see the same numbers as we go towards the middle. Well, why is that? The next one says, write the equation for each shaded product. So let's go ahead and start here. So here I've got 9 times 0, right? 9 times 0 equals 0. And then next I've got 8 times 1. 8 times 1 equals 8. All right. Then I've got 7 times 2. 7 times 2 equals 14. After that, I've got 5 times 4 is 20. Oops, I'm sorry. I skipped 6 there. 6 times 3 equals 18. 6 times 3 equals 18. And then I have 5 times 4 is 20. 5 times 4 equals 20. All right. Well, let's keep going. Now I've got 4 times 5. So 4 times 5 equals 20. And then I've got 3 times 6 equals 18. And then I've got 2 times 7 equals 14. 1 times 8 equals 8. And then 0 times 9 was 0. I want you to go ahead and pause the video if you have not filled this in, because this is what we need to write down. And we're going to use these for our next question. So if you haven't written these down, pause the video right now and write those in. Now we're going to go ahead and take a quick look here at number 7. There we go. All right, take a look at number 7 with me. It says, look at the factors you wrote and use a property to explain why the pattern for the products is true. All right, so look at these different ones and see if you can figure out a property that tells why this is true. Well, I hope you paused your video and you were able to kind of look at this, but when I look across 5 times 4 and 4 times 5, 6 times 3, 3 times 6, 7 times 2, 2 times 7, 8 times 1, 1 times 8, 9 times 0, 0 times 9. These are the same problems that are in the same fact family, right? Well, if these are in the same fact family, then when we flip them around like this is called the associative property. All right, the associative property. The associative property tells me I can multiply these in any order and still be able to get the same answer. All right, so the associative property is what helps me out. Well, number 8, it says shade a line in the multiplication table to show how this pattern is true for other products. All right, so when we take a look up here, what are some other ones? Let's go ahead and choose, let's start with 5 times 0. So I'm going to shade that in. All right, if 5 times 0 is 0, 4 times 1 was 4, 3 times 2 is 6, 2 times 3 is 6, 1 times 4 is 4, 0 times 5 is 5. Can you go ahead and try to find another one? This is the same thing. 0, 4, 6, 6, 4, 0. So they go back and forth just like before. So now, can you find any others? Yeah, most of these do, right? We can go through the same step as a diagonal going up and down. And if we do that, then we can find that we've got the same numbers over and over, including if we go way over here, 9 times 5. If I start with 9 times 5, then 8 times 6, then 7 times 7, then 6 times 8, then 5 times 9, 45, 48, 49, 48, 45. It's the same pattern that shows that same thing. All right, third grade. Well, you guys have done a fantastic job today. I hope that these are starting to make some sense to you and you guys are starting to put it together. I hope you guys have a great rest of the day and we will see you next time. Have a good one.